So here we would have to draw the diagram. So we can draw the 4 boxes. And we have lowercase m, capital M, lowercase m, capital M. Now we have this, they're all connected. So we can connect all of them, and then we have a y-axis, a vertical axis here, and then our x-axis is here. And we can say that this distance here is 1.5 meters. We know that this distance here, obviously not drawn to scale, is 0.5 meters. And then we can say that this distance right here is also 0.5 meters. So essentially, we're trying to find the moment of inertia. So we have lowercase m is giving us 2.2 kilograms, and then capital M, the question says that capital M is 3.4 kilograms. So for part A, when we're finding the moment of inertia about the vertical axis, this would equal, according to the definition of the moment of inertia, the sum of the masses times the distance r, I, y from the vertical axis. So essentially, it would be the mass, the magnitude of the mass multiplied by the mass's distance from the axis of rotation, in this case, the y-axis that we've defined. So we can say that this is going to be equal to m times 0.5 squared plus capital M times 0.5 squared plus lowercase m 1.0 squared, and then we can say plus capital M 1.0 squared. This is giving us 7.0 kilogram meter squared. So again, this would be our y-axis. And then for part B, they're asking us for the moment of inertia about the x-axis. So this would be the sum of the masses times the distance from the axis of rotation. In this case, it would be the x-axis. So this would be 2m plus 2 capital M times the distance. In this case, it's always going to be 0.25, and this would be squared. So we can say that this is going to be equal to 2 times 5.6 times 0.25 squared, and this is giving us 0.70 kilogram meters squared. So and the question C is asking us how much harder would it be to rotate one axis against the other. So because the moment of inertia about the vertical axis is greater than the moment of inertia. Rather, we can be more specific and say that the moment of inertia about the vertical axis is 10 times the moment of inertia about the x-axis, so the horizontal axis. So essentially, because of this, it will be 10 times harder to rotate about y-axis. So that's essentially what the moments of inertia means. So because the moment of inertia about the y-axis is 10 times greater than the moment of inertia about the x-axis, it's going to be 10 times harder to rotate about that vertical axis. That's the end of the solution. Thank you for watching.